VMware and Linux. In this nugget, we'll be addressing VMware and Linux, but before we get to that, I want to cover actually three things. First of all, I had a misspelling in my last nugget, and I know someone's going to call me on it probably, especially since I'm always critical of other people's spelling. Anyway, I mentioned CENTCOM, and for some reason I spelled it phonetically like this, CENTCOM. This is actually Central Command, which would be CENTCOM. Anyway, that's what got broken into. I mentioned a while ago, and they had terabytes of data that got stolen. But we're going to start off in this nugget talking about the security triangle. It has to do with security, functionality, and ease of use, and there's kind of a divergent relationship between all three of those items. We'll take a look at that, as well as the 5 stages of ethical hacking, although really we're going to be addressing that throughout the rest of our series. I'm going to talk about VMware, some of the advantages of it, and how to use it. And then we're going to spend the majority of our time getting our feet wet with Linux. Now, none of these things here, where we're spending the majority of our time, really are even on the exam directly, but we need to cover them because hackers use these tools regularly, and it's much to your advantage to be familiar with these. Also, before we get started, I want to point out that this is likely to be a very long video, so if you need to take a break partway through, certainly feel free to get yourself a cup of coffee or maybe a 5-hour energy drink. I don't think you'll actually have to take 5 hours to watch this whole thing, but you can at least take a break in the middle and come back refreshed. Now, at the beginning of this nugget, I want to address a couple of topics that I didn't really have time to do in our last nugget because it was getting to be a little longer than I wanted it to be, and maybe longer than you wanted it to be. So here I'm just going to address a couple of cleanup items from Module 1 still. One of those is the security, functionality, and ease of use triangle, and that's what we have right here. This is really a very simple concept, and it doesn't require a lot of explanation. You just have to understand that the closer you get to any one of these concepts, the further away you get from the others. So, for example, if your users are griping and complaining, we've got to have something that's easy to log on to, easy to use. I don't know why you have to give us all these secure IDs and smart cards and fingerprint scanners and whatnot. We want it to be easy, okay? So, what we would do is if we bowed to their will, then we would have to move away from security, wouldn't we? Because we would no longer have secure IDs or fingerprint scanners or even maybe optical scanners. And we would also move away a little bit from functionality potentially, because that might take us away from access to certain resources that we would need to have that we could only authenticate ourselves with maybe a secure ID or something like that, maybe a VPN solution or something of this nature. So that's one idea there. And if you take a look at the other directions as well, we would say, well, now we want to make sure that we can gain access to the resources we have to have. And if we go this direction, then it could be that we're trying to our users are trying to gain access to things that they don't really have the right to access. So maybe we're loosening up our NTFS permissions, for example, in a Windows system. Well, if we have to loosen those permissions so that users have fuller access and more functionality, we're moving away from security. Now, that's not in this case, it's not really moving away from ease of use. It's actually making it easier for the user as well. So this may not translate across all things. But the main thing we want to keep in mind for an ethical hacker's perspective is security here. If we say we want a higher level of security, then we have to understand that we're going to lose a little functionality. Folders and directories that users used to be able to access, maybe they won't be able to access those anymore. Websites or intranets that users used to be able to access, they can't access those anymore because they don't really have a job functionality that requires those things. So we're moving away from that functionality, although you do still have to give users access to what they really need to have. Also, the more secure something is, and this is the big thing right here, the less ease of use it has. They can't just walk up to a machine and access to the desktop without a logon. And they may have to also use a smart card, or they may have to use some kind of a biometric. For physical security, they may have to scan a key card in order to be able to get into certain rooms. Or they may have to sign in with the security guard, all those sorts of things. And you get the idea of how this kind of a triangle. And then the second topic that I ought to address here, also from Module 1 really, is the 5 stages of ethical hacking. Now, I'm not going to go into a great deal of detail on this because virtually the rest of our entire course covers these 5 topics. So, but we do want to understand the basic flow of how this goes. First of all, in order to perform a good hack, whether it's a black hat hacking attempt or an ethical hacking attempt, really, you need to perform good reconnaissance. Another good hacker friend of mine, he's really, really good. He says that 95% of his ethical hacks are done in reconnaissance. The remaining 5% takes place somewhere down in the rest of this. This is a very, very high priority, really, in performing a hack. And we have a tendency to think that, oh, if you're going to be a good hacker, you need to have the best tools and know how to do, all kinds of programming, and you can really get into the dark arts, so to speak, of hacking. Well, in reality, could be very, very simple. You might even be using public tools that are available on the internet that anybody can access, or you might even do a lot of this just by having a conversation with somebody. There's also scanning. This can be done a couple of different ways. It might be a passive scanner or an active scanner. We'll address some of those scanning tools a little bit later on as well. But for example, a passive scanner would be something that does not actually send anything notable to the destination host. So it might not even know that it's being scanned. Whereas certain other kinds of scans, maybe a Christmas tree scan is what we call with Nmap, for example, that sends a whole bunch of stuff to the other host. And so they, if they have the right security prevention tools or intrusion detection systems and so forth running on that destination, they might immediately be able to tell, hey, we're being scanned. So that would be an active scan, and you just have to learn how to do that stealthily, or stealth scanning. There was also a matter of gaining access. Once we've done our proper homework here with reconnaissance, and now we've scanned the network and know what ports are open and stuff like this, we can gain access through a variety of different tools. Maybe Metasploit, which is probably the more common tool that's used out there. Certain other things that will actually crack open a security hole, and now we've got access in there. Maybe we've got shell, something like this, so that we can start to perform commands on the destination host, and then we need to maintain access. Sometimes that'll be done through creating or exploiting a service, or creating a user account there that looks harmless, but in reality we've made it an administrator, something like this. And then we'll cover the tracks. And unless you're a suicide hacker, you're certainly going to want to cover your tracks, because you don't want this to get traced back to you. And so this could mean deleting event logs and things of this nature. And again, all of this stuff we'll be covering throughout pretty much the rest of our course in one way or another. And now then, the next topics I'm going to address are not actually exam objectives, but they're very important in order to be able to become a certified ethical hacker. They're just tools that you have to know. They're kind of a given, even with the certified ethical hacker exam, only because these are tools that all the hackers use. So one of the things that we have to do is we have to have a good understanding, first of all, of virtualization. Now, what this is where you'll have, let's say this is your physical box. This is your computer that you have right here. And let's say that it's running, Windows 7. Okay? Now, what kind of tools do hackers very often use? Very often, they're going to be using Linux. Well, I've already got Windows 7 installed on here. What can I do? Can I dual boot? Yeah, sure. It's kind of clumsy, and you have to restart the computer every time you want to go into Linux. But you could do that. The other thing is, you might have to also know some things about servers. So you might have to install Windows Server 2008 on here, or a Linux server, or even the Mac OS. All kinds of things you might have to install, and that's not really feasible to put on a single machine. So what we do is we leave Windows 7 on there, and then we install a third-party product, such as some of these other ones that I've mentioned up here. I'll get to those in a moment. And then within Windows 7, we can now have, Linux right here. We can now have, over here, you can have the Mac OS. I've done that as kind of a way to hack that. I kind of hackified a way to install a Mac OS X inside of a virtual machine. Okay, so you could do that. You could install Sun Solaris. You can install lots of different operating systems in here. Windows Server 2008. So all of those operating systems can be operating inside of actual software while I've got Windows 7 running. For example, right now, I am running Windows 7. That's the operating system I'm using. The whiteboard stuff that I'm using here is actually Photoshop. It's actually overkill for what we do here, but I'm also a professional photographer, so I have it and I use it. But what we have here is I've also got VMware running. Let me show you an example here, and I'll just drag this over. You can see I've got VMware going on right now. And it's got several different virtual machines that I can use of different operating systems, most of them Windows operating systems. I've also got some Linux items going on here, and Ubuntu's running. Here, for example, I've got a good reason to use virtualization. Even though I'm running Windows 7, this software right here, VMware Workstation, I've got another operating system kind of running underneath the covers here. It's called the Windows 8 Developers Preview. Now, by the time you get this recording, Windows 8 may already be out, or it may be in beta. This is a very early release of Windows 8. Now, I don't want to install this on my physical daily productive machine. That's why I put it inside of a virtual machine, because if this blows up, it does not affect my productivity at all. In fact, what I also do is I just take snapshots. So let me show you here. I take snapshots of it so that when I went to a baseline over here, I just took a snapshot of it in a known good condition. And that way, if my current state here, if I installed some software or I did something tricky with it and it totally caused the OS to blow up, then I'm not having to reinstall Windows 8 again. Instead, I can just go back to my snapshot here, and I choose Go To down here, and now I'm back at a known good state. You can even do auto-protected snapshots, which I'm not using here, but every now and then they'll just take a snapshot automatically for me so I can go back to an earlier point in time, again, preventing a lengthy reinstall. And then in addition to working with Windows 8 here, another advantage of virtualization is I can run multiple operating systems at once, as much as my hardware can support. So for example, I've got 8 gigs of RAM and plenty of hard drive space and such, and you know, quad-core processor. So I can run several operating systems if I want. I've only got 2 running right now. I can also run, here's Ubuntu, so a lot of my Linux demonstrations will be done from here. And then I've got a Linux attack server that I also work with that's got a whole bunch of hack tools kind of pre-installed on it that I'll be using to demonstrate some other things later on throughout our series. So anyway, in terms of virtualization, it's really now a core IT skill. Anybody that works in IT knows and understands virtualization. They should have a good grasp of how to use it. They probably are virtualizing a lot of different things. In terms of the products, there's primarily going to be Microsoft's product of Hyper-V. If you're running Windows Server 2008, that's just kind of a built-in version of virtualization that they have. It works pretty well. I don't have any complaints about it, but I still primarily use VMware. There's also Virtual PC, which is something that you can use outside of a server, and you can install that, for example, on a client Windows operating system. And it's probably most closely aligned with VMware Workstation. It kind of competes a little bit with that. There's also Parallels for the Mac. These are both Mac products right here. Parallels is a competing product where, again, you can run multiple operating systems. It's not possibly quite as robust as some of the higher-end products like Hyper-V or VMware's higher-end products such as the ESX server and so forth. There's also on the Mac side VMware Fusion. I do run that over on my Mac computer. I have a PowerBook, or rather a MacBook Pro that I work with there. And then there's also VMware Workstation, and that will run on your Windows operating systems. And it could be on a server. It's just because it's called Workstation doesn't mean you can't run it on a server. You certainly can. And it's a less expensive version of virtualization than something like their ESX products. Anyway, you don't need to know all the feature lists for all of these things. Probably for most hackers, you're sufficient to work with something like VMware Workstation, Virtual PC, or if you're working with a Mac, either one of these, although I do prefer VMware Fusion, at least for what I use. So the reason why I use VMware, and of course, there are other products like I mentioned earlier, but one of the reasons why you want to use virtualization at all is because you have consistent and repeatable results that you can get out of it. So for example, the virtual hardware is reliable. If we go into VMware here, let me just go to any machine here, then we can see that I can go into the settings. I'll right click here and choose settings, and all of these pieces of hardware that are available to us, I can add or subtract from that. For example, the memory. If a gigabyte's not enough, I can add more to that. I've got a quad-core processor, so I'm using all 4 cores there. I could back that down to fewer if I wanted to. I can add additional CD/DVD locations if I want to. I don't want to use a floppy drive, but I can do all kinds of things here. I can adjust the networking. So right now it's bridged, so it's basically the same as directly connected to my physical network. I've got a DHCP address if I want to, that's issued from a physical server that's on the network, or I could use network address translation, or I could do things such as custom networks or host only. The advantage of these custom or host only ones is that it can virtually be like a VLAN. So if I did a specific virtual network like this, that would be a VLAN, and any other virtual machines that were also on VMnet2 those machines could communicate with one another, but not with any other computer on the network, both physically or virtually. Similarly, we could do a LAN segment here, and it's grayed out right now because you can't adjust some of these things while the machine's actually running. But you can see the various flexible items that I have here. It gives me quite a bit of capability there in working with that hardware. And then you can also copy and or move virtual machines. Sometimes I'll create a virtual machine that's exactly configured the way I want to make it work. And then if I have a client that I need to visit and to show them or demonstrate them something on that virtual machine, I'll copy it over from my VMware workstation on my Windows 7 computer over to my MacBook Pro and run it under VMware Fusion. And there you can copy back and forth between the two, even though one is a Mac product and even though the other one is a Windows product. Seems to work very, very well. So there's also P2V. That stands for physical to virtual. So maybe you've got, this is something that's really going on right now in the IT world. That's not a very straight server rack, so let me try that again. This is not really a certified ethical hacker issue, but in a lot of places you'll have a rack where there's several different servers installed here. There might be a dozen servers here, physical servers. But we might want to get higher density in our rack space because maybe we have other servers that we want to put in there for other purposes or something like that. We could conceivably do a P2V migration. So we take all these physical servers and we could migrate all of this over here into a virtual machine environment. So we've got maybe Windows Server 2008 running here in Hyper-V or a VMware ESX server, something like that. And we could take all these physical machines and migrate them over here. Most of the virtualization products have some kind of utility that allows you to migrate over there for higher rack density. And then I can install other things here or just free up space on the floor. So we don't have quite as many racks, for example. I can also do a P2V for a non-destructive test. Maybe one of these is a critical server that if I'm doing a penetration test, the client does not want me to directly hack into it. Maybe this is their file server here. Well, they don't want me hacking into that. Maybe this is their SQL server, and this is where all their business actually done, their online transactions, things of this nature. We could take these things, migrate them over here again to a virtualized environment, and take them, if they'll fit, even onto my laptop and perform all of my tests right there without actually touching their production network. I can also use snapshots, as I mentioned earlier. If something goes horribly wrong, I can just go back to a previous configuration. And then we can also do the network isolation that I talked about earlier, and then I just demonstrated this server density here that we just took a look at. Now, let's take a look here at Linux, and this is something that we'll very often have in a virtual machine as we work as hackers. This is something that, if you're already familiar with Linux, all of the stuff that I'm showing you from this point on will probably be mostly a review for you, but many of us are probably Windows administrators that are just starting to get started in the hacking world, and so this will be very important to understand at least the basics of Linux. This, of course, will not be by any means comprehensive, and I'm really just competent with Linux. I'm not a Linux genius like Sean Powers is, who's also a CBT Nuggets trainer and does our Linux series. You might want to look into those if you want to get in-depth knowledge of Linux. Anyway, Linux was invented by some guy named Linus Torvalds, and he wanted to take Unix, which typically had been installed only on very, very expensive kind of mainframe types of operating systems or architectures, and he wanted to install that on a cheap, inexpensive x86 architecture. And he was able to do so. In fact, the first versions of Linux could fit on a floppy disk. And in fact, many of them still can. Some of them can fit on a thumb drive. And you can run it directly from a thumb drive or a CD or a DVD, for example. It also fits on many other platforms. It installs on some pinball machines, for example, or gaming kinds of operating systems. It'll install on some phones. So lots of different things you can put it on. Lots of appliances. It's the hacker's operating system of choice. A couple of reasons for that. Number one, it's free. Hackers are kind of notoriously cheap. We don't like to pay for things, and if it's something that you do have to pay for, usually I won't say we, I'll say they. Usually they'll steal it, or pirate it or something like this. So since Linux is free in the first place, very easy to work with, and typically in the past, a lot of folks have used something like Red Hat, but it's becoming more expensive right now with the way that that's being distributed. So a lot of folks right now are using Ubuntu, and that's exactly what I'm using. not only is it free, it's also really, really good. Very easy to work with. Also, very flexible. This is something where a lot of hackers will be able to do things such as package their own Trojans inside of what looks like a normal operating program. So they might take, I don't know, the Windows calculator, and they can pack. Oops, sorry, folks. I got to pause recording for just a moment. Hold on. Okay, I'm back. I got a little excited there, and I accidentally pulled apart the little pen that I use that makes all these markings and things here, and it flew across the room, so I had to go chase it down. Anyway, it's flexible because you can take something like a normal Windows program. Maybe this is, Windows Calculator. I'll put a couple of buttons on here. Apparently, the Windows Calculator is not smart enough to do any more than add two digits together. But anyway, I could package inside of that a Trojan using Linux, and there's several different utilities that I can use to do that. And then when I copy it over to a user's computer, it looks like the normal calculator to them, but when they open it, it actually takes this Trojan and launches that into memory, and now I've got control of their system, potentially. So using Linux, you can do a lot of different things like that. Very, very flexible. Also, very small resource requirements. You can install and run Linux in, depending on which one you've got, 128 megabytes of RAM or 256. Some of the other ones, some of the attack servers that I run, actually only use 256 megabytes of RAM. Try doing that with Windows. Okay. Also, and I'm not going to get into the bumper sticker argument here, but most hackers will generally consider it to be inherently more secure than Windows. And you can say that that's really only because more hacks come out against Windows because it's more high profile. But on the other hand, Apple just became the world's most valuable company at the time of this recording. And so they're a pretty big target too right now. Anyway, I'm not going to get into that argument like I said a moment ago, but it is generally considered more secure than Windows, and so that's the platform of choice for most hackers. Now, when it comes to using Linux, what do you actually have? First of all, you can download Linux from a great many sources right now, including kind of homemade distributions. You can kind of come up with your own version of Linux if you wanted to, but you can get them for free from many sources. You can still get them from redhat.com. You can get them from ubuntu.com, and that's the one that I'm primarily be using. Most of the time, they're going to be in an ISO file so that you can install them directly onto physical hardware or into a virtual machine. And some of the older versions of Linux, when you first start them up, they only give you a command line interface. And at its core, Linux is a command line only UI because administrators from the Unix environment typically only had command line. There was no mouse, no Windows, nothing like that. At least back in the old days. Later on, they had X Windows and stuff like that. But anyway, for Linux, for the most part nowadays, with things like Ubuntu and Red Hat and so forth, they will have a UI. Normally, it's going to be something like GNOME. You can choose a number of different UIs that you can select from. They all have different characteristics and advantages, and I'm not going to discuss all of that. Most of the time, I'm using GNOME these days. If you started off with the CLI version of Linux, and you did not have a UI like GNOME, a windowed operating system, then you would type Start X after you'd installed GNOME, and then it would launch the UI for you. Most of the ones right now will launch directly into the UI, though. Also, Linux is case sensitive, and this can be a bit of an issue for old Windows administrators like me. Let me show you, for example. Here I've got my installation of Ubuntu. This is pretty clean installation. I haven't done an awful lot with it, just minor customizations here so far on this one. But let's say I'm in the file system, rather in the terminal here, and I wanted to change directories. For example, if I wanted to change directories, it's much like we would do in Windows. We just type CD, for example. And then, but instead of doing a backslash to go to the root, instead here, that doesn't do that, as you can see. Instead, what we would have to do is you'd have to CD / instead of a backslash, and that would take us to the top level directory. And if you want to know where you are, just type pwd, for example. I'm getting ahead of myself because I have another whiteboard that'll talk about a lot of these commands, but that will tell me right now that I'm at the root, which is the slash. What if I wanted to change to the home directory? Because there is a directory on here called home. Well, I could do change directory to home. Okay, and there we are. Now, what if I wanted to change to the trainer directory? Change directory to the trainer. Oops, no such, Well, if I do an ls, that shows me what's there. Sure enough, there is a trainer directory. Why can't I get there? Look at the capitalization. Come on, James. CD trainer. Now I'm there. See? And that's what I was talking about earlier with this capitalization or the case sensitivity to Unix. And that does take some getting used to. Also, I'm going to talk to you a little bit about navigating the file system. I'm just going to briefly address that here in a moment. But we're going to find that it's drastically different from a Windows environment if that's what you're accustomed to. In fact, I think I'll just show you that right now. Let's go ahead and take a look here at Ubuntu, where I've got the UI loaded, as you can see here. Now, this is much easier now than it used to be, where you had a command-line only edition of Windows. Now, we could just go to Places up here, and you can see that you can search for the documents, look for the documents, go to the computer. You can browse the file system, you know, and so forth here. You could look at any of the documents that you have and the like. This is very much like Windows. However, I'm going to show you how to do this from the command line because it's kind of a core Linux capability, and there will still be things that you will do from the command line as a hacker. Also, because a lot of the utilities that you get and the tools that you'll download, they are command line only tools, so you'll need to know how to work with some of this. So, to begin with, let's say that, you know, here I'm logged in as root, and if I just do a pwd, then we'll see that I'm in the root directory. Now, the root account is the equivalent to the local administrator account that you would have on a Windows-based system. It pretty much has full control over this operating system. Now, other users will not have access to the root directory. Now, this is equivalent to the root user, the person that's interacting with the operating system right now, me in this case. This is equivalent to my home directory. For any other users that are on the computer, they will have their own home directory. So, for example, if I go change directory to the root, and by the way, in Linux, it's backwards from what we would do in Windows. In Windows, we would do a CD /. In Linux, we do a CD / to take us to the root directory. If I want to confirm which directory I'm in, I type pwd, and it shows me just this /. That means that I am in the root. If I do an ls, that's the equivalent to the dir command. Actually, let me show you this. I could do a dir, and that would show me things just like Windows would. However, if I do an ls, notice how it's different. It's color-coded so that, for example, directories are in this blue color, and the files are here are the, I don't know what you call that, but more of a cyan color, I guess it would be. Now I'm going to go ahead and clear the screen. In Windows, we would do a CLS. You don't do that in Linux. You do a clear, type the whole word clear. And if I do an ls again here, let's say I wanted to go to, the home directory. Okay, so I would cd to home, and there I am. Now if I do an ls again, I can see there's only a single user account there, the trainer account. Now, like I said earlier, Linux is case sensitive. So if I wanted to change directory to the trainer directory, it would say no such file or directory. Why? Because it's lowercase here in the actual folder. So I would do a cd trainer instead, and now I'm there. Okay, so that's kind of how we get around in the very basics of Linux. Now, since I'm actually logged on as the root account here, let me just clear this up right now. I'm going to change directory to root, and if I do an ls here, we'll see that I have several different common things that users would have in their own home directories as well. And I want to change to documents, so I'll change to documents again. Here, I can also do shortcut kind of stuff by using the tab key. If I do a D0, or rather a DO, and press tab, nothing will happen right now. Why? Because it's kind of trying to predict what I want to go to, but I don't have uniqueness yet because there's DO there for documents and DO for downloads. If I do a DOC and then press tab, then I have enough uniqueness that it will allow me to go there. So just by pressing tab, once I've typed in enough unique information, it will get me the conclusion of what I was trying to type. Same thing happens when we're trying to work with various files and the like. Very good shortcut to know about in Linux. Also, by the way, applies to Windows. Just, I don't know if everybody uses it there, but it's also available there. Now I'm going to get ahead of myself just a tiny little bit here and work with a little bit of text so I can have a file that I can move around for you here. So if I wanted to use probably one of the most fundamental text editing programs available, then I would probably use cat. Okay, now cat, what it does is allows you to create text files using the greater than and then whatever the file is that you're trying to work with. If it already existed, I'd type the name of an existing file, but since I don't have one, I'll just call it, myfile.txt. Also in Linux, file extensions don't mean anything. In Windows, this would be something that I could open up with Notepad, for example, and be a plain text file, and when I double-clicked on it, it would have a file association. In Linux, it doesn't work with that. I could type it with or without an extension. Doesn't really matter. Now that I've pressed Enter, this is actually, I'm in my text editor right now. We don't see any fancy windows. We don't see any icon bars or save buttons or anything like that. No menu system. I just start typing. So I might say something like, short, bald guys are so sexy. Well, that doesn't mean I'm attracted to short, bald guys. What I'm trying to say is that I am one. The more I talk about that, the worse it gets. So I'm just going to press enter here and try to quit out of this, okay? Now, to quit out of this cat text editor, what you'll do is just press Control D, and then that's it. Now, if I do an ls, you see that I've got a myfile.txt file. And if I do if I don't want to actually open the text editor to see what's in it, I just want to see the contents of it, I can use the more command, and I could do more myfile.txt. Again, I'm pressing tab to automatically fill the rest, and there we go. Now, if I wanted to add on some more text onto this, I could do a cat space and then two greater than symbols and then myfile.txt again. And now I'm back into it. Now, notice that it does not show me what I've already typed in there the same way that a normal word processor would, like Microsoft Word or something like this. Although the file is open and I'm editing it, all I'm actually doing is concatenating to it. So anything I type from this point is going to be just added to the previous. So I could even add more text to this, maybe and smoking. Okay, something like that. Boy, it sounds a lot like I'm overcompensating there, doesn't it? Let's just move on. Okay, so then if I wanted to quit this now, and I would again just go ahead and press Control D. And then if I do a more again for my file, and I'm pressing the up arrow here as well, by the way. You can go use the up and down arrows to go through previously typed commands so you don't have to type quite so much. And again, now we can see that it's the complete document, including the added part that I typed in right here. So that's kind of how you can work with basic text in Linux. But that's not my main point in creating this document. I just needed to have a document that I could, move around and stuff. Let's say that I wanted to copy that to a different location. Well, if I do let's do an ls again. Remember, there's my file, myfile.txt. If I wanted to copy that, I would type cp instead of the word copy like we do in Windows, and I would copy that to, let's say, root and then desktop. Okay. And press enter. Oops, I did something wrong, didn't I? Oh, I forgot to put the name of the file in there. You got to do that too, folks. And it's myfile.txt. Okay, so press enter, and then we should see that appear on the desktop back here. If I move the window this side, sure enough, there it is. Okay. Now another thing I could do is, what if I only wanted the file in one location and I wanted to remove it from its current location? Then I would just do an rm for remove myfile.txt, and now if I do an ls, we see that there's nothing there anymore, and it's only in the desktop. So if I change directory now to root desktop and do an ls, I guess I don't see one, right? If I do... Oh, I'm trying to type too much at once, aren't I? Change the directory to the desktop and then do an ls. That's what I was trying to do. Then there's my file.txt. What if I wanted to rename that file? In Windows, we type ren or rename. Here we just type... we do actually move it. You move it to the same location where it is, though. Okay, so if I wanted to rename it, I would do actually mv for move, and then I would type in the current name, myfile.txt, and then I would type in the replacement name that I wanted to rename it to. And let's just be honest here. Let's just call this fiction. .txt. And we'll press enter. And then now we'll see that it's changed. You can see it in the background there it's changed. And as well, if I do an ls, we'll see that it's also changed. And of course, the move command can also be moved to actually move the file. And I'll just call this fiction.txt. Move fiction to, again, root. Maybe if I want to move it back into documents, I'll see it disappear from the desktop. And then I'll go to documents again. And then we see that it's now there because of the move command. Alright, now I also want to talk to you about the file system and some of the more significant directories. In order to do that, I could go just back to the root here and list them here, but I think for the sake of making it more intuitive, I'm just going to actually show you their equivalent to my computer that we have in Windows. That would be found here on Ubuntu under Places and then Computer. And you can see with these, you can click and drag these around, and I dragged mine up here too. Actually, I dragged two of them now because I put that one up there. I meant to put only one, but I already had one up here, and if I click it, you can see again it's very similar to my computer in Windows, and I can browse through the local file system. Now, I'm not going to elaborate on all of these, some of them a little bit more obscure than others, but I'm just going to go through some of the more significant ones that you might have to know about. For example, the bind directory. This is going to contain system critical programs and different things here. So, for example, we'll be able to work with the cat command here. Remember I used cat earlier to create a file? Well, a lot of that and a lot of the other commonly used files are located here. Also, there's the boot directory, which has boot files. There's the dev directory over here, which is going to have files that directly access the hardware. In Linux, even your devices, and that's what you can think of dev as devices, are actually represented by files. Even my CPU is actually represented by a file. So everything's in the file system. The etc is going to contain mostly configuration files. So for example, if I had wanted to configure something to be a little bit, operate a little differently, or I wanted to change something about the sound qualities or the display or something like that, many of that could be done through config files. There are files that often end in .config here, and I could work with those items there. So that's what etc often is. Home is where individual users will have their own home directory. It's a lot like My Documents in Windows. Okay, and then we'll also have lib, which is where the mission critical libraries are, similar to what we have with DLLs and those types of libraries in Windows. What else? Here's media. Media is going to contain folders that are attached to my system, such as floppy drives, you can see here, or the CD, which I've got installed over here. That's also what appeared on my desktop. You might have seen that earlier. You can see that in the background there. And if I double click on it, it just takes me to those that particular location. So a couple of different ways to get there. Optional software could be in the opt directory. If I have things that are temporarily mounted, you can use the mount command to mount things in the MNT directory. I don't have any additional media to demonstrate that with, but you could certainly do that. You would use the mount command, and then to unmount it, you would use umount. Not unmount, but umount. What else have we got here? There's root, which I already talked about. Again, it's the same as a home directory for these other users. It's just the root's home directory is at the root of the file system here as well. sbin is similar to bin here, except that these are commands that are mostly designed to be run only by the root account. Temp is temporary file, similar to what we have in Windows. These are usually deleted at every restart. USR has several different subdirectories, and these are going to be things such as additional bin directory here that virtually every single program we are going to use is going to be located in the bin directory. Oh, by the way, the USR here, let me go back up a step here. USR doesn't stand for user. That stands for Unix System Resources, although I'll very often just call it user anyway, just because it's kind of phonetic that way. But it'll have, like I said, the binary programs that we'll very often use. Also, here's something else, local. Okay, and on local, you can have additional items that you dump in here. These might be programs that I have manually compiled here and dumped them into this location instead. It's just a common location for them. They don't have to go there, just as kind of a force of habit, so to speak. They very often will. And then beyond that, you can use this also to copy files, move files, and so forth. You can see I can just right-click on something, cut, copy, kind of common things that we've seen in the past. You can also make a link to something, and this is very similar to a shortcut. So I could then cut this, or rather move this to the desktop, for example. And then if I close this up, then now we can double-click on it, and it works exactly like a shortcut would within Windows. I played Solitaire, by the way, last night for the first time on Ubuntu, and I won the very first time I've ever played it. Now I'm afraid to play it again because you can't ever have that much luck again twice in a row, so I'm just going to leave it alone. Anyway, to delete stuff, you can then right-click and choose Move to Trash, or you can just drag it down here, similar to the way you would on a Mac, for example, or in Windows. Just drag it down here to the trash can. There it goes. Didn't seem to want to cooperate at first, but there it goes. I also talked about viewing and editing text a little while ago. Remember, we used the cat command. We also to create a text file and to add to a text file. We also worked with another command called more, and that's what allows us to view the documents. Okay, I'm going to go ahead and clear my screen here so we get a little bit cleaner view. And let me try to remember where I am here. PWD will show me my directory. I'm at the root, so I want to change directory to the root. And how about documents? Okay. All right. So now that I'm in here, I could do a few different text editors. There's a whole bunch of them out there. I can't really go through all of them. I don't even have all of them installed. But just some of the more common ones would be something like Kate, for example. I don't actually have that installed, so it'll tell me that I don't. And this is kind of cool. We'll get to this a little bit more later on when we talk about installing applications. But if I wanted to install Kate, all I would have to do is type apt get install Kate. This is a lot simpler way of installation than what we've had sometimes in the past within Linux. And what this does is it goes out to the appropriate websites out there on the internet, downloads all the components that it's necessary and dependencies necessary to install Kate, and then it would do so. And this is just a simple text editor, something like WordPad if you want a Windows equivalent to it. There's also gedit. Okay, and if we can just type that and open it up. This is, again, similar to WordPad. It's really just a matter of preference. These are plain text editors, nothing fancy here, but I do get the ability of, that's different than what I would with Cat. With Cat, there's no save buttons or anything like that. There's no UI like this. There's not directly, at least, any clipboard kind of an item. There's no print functions. And you can see there's several menu items that we have up here. Okay, so you can check spelling and so forth. And you can also work with multiple documents at once, so I can have 2 or 3 different documents going on here at once, whereas with Cat, I really just don't get that. Oh, also notice this. What if I wanted to go back to this terminal window and type something else in? Doesn't look like I can. Why is that? Well, because you see, I've got this open. If I close this, then it returns me to that. If you want to type in a command that opens up a UI or something else that would otherwise pause this terminal, then what you have to do is to type in the command plus an ampersand and press enter. And then now you see I've got this open, and in the background I can still go on to type other things here as well. But anyway, what I was trying to show you there was with cat, for example, and if I were to do cat, and then whatever the name of the file is, hello.txt, then there's no such thing as a file save as or anything like that. You can click on file, but guess what? That doesn't really relate to the cat text editor. That's really just the terminal window. These are all terminal items that I'm working with there. So nothing really much for us there. I can press Control-C to get out of that without having to actually save that file. Now, another text editor we could use, this is an old-time, classic Linux one, would be VI, and we just press Enter here. Now, this, again, doesn't give us a fancy UI or anything like that. Didn't even used to have this much instruction, but now at least it gives you this much. But if I wanted to type in, hello, friends, I would just type the letter I to get into insert mode here, and I just type hello, friends. Okay. That spelling didn't go so well. So let's say it's a little bit awkward here, and I'm trying to get out of this without saving the file, which is the case. So I'll just press Escape, and then colon, and then Q. Now Q, if I do it right now, it would tell me that I haven't saved the file in so many words. But I want to say, get me out of here, out of this awkward moment, and don't save anything. Just I'm going to give it the exclamation point. You can see down at the bottom. That's where I'm typing. Q exclamation point, enter, and I'm out of that moment. Now, returning to our whiteboard here, there will be many times when you don't understand or don't know the various commands necessary to enter. For that, you can go to the help and the man. Go to the man for some help here. Let's go ahead and take a look at that. If I go to the right screen. Okay, so let's say that I needed to know more about one of my editors, maybe the cat command. So if I do cat, maybe I don't know all the various options. I can do a -- help, and that will show me all of the options that are available here. You can see a number of different things I could type. I could also, some of them will also have a man file. It may or may not have one. Most of the command line ones I would say do. But I could type man, and then again type, what am I looking for? Cat, man cat. And then it will show you a more complete help file. This actually is a help file. It's usually going to be the name of the executor, name of the command, .man. So this is actually opening up a .man file. And you can see here that it goes a page at a time. If I press enter, it goes down one line at a time. If I press the space bar, it goes down a whole page at a time. And you can just keep going on down until you get to the end if you want to. And then if you don't want to get all the way to the end or at any time, you can press Q, and that will just take you out of the man page. Now, I'll also need to work with the network configuration. You might need to do things such as changing an IP address, for example. So here, if I'm back in my UI here, I could do an ifconfig to identify my current IP configuration. Now, wait a minute. You might be looking at that and saying, James, come on, genius. You've been misspelling all day, and you did it yet again. It's not ifconfig, it's ipconfig. Well, hold on there, Mr. English major. This actually is ifconfig because in Linux, it's interface configuration. In Windows, it's IP configuration. So I did type it in correctly. And then we can see here that my current IP address is 10.10.10.71. Well, I just realized that's actually not the IP address I wanted, because for my instructional machines, I usually make them .70. So how can I change that? I could do an ifconfig, actually Yeah, that's right, ifconfig. I don't know why I've got these weird characters in there. And then I could do a ETH0. I have to identify which interface I want to work with. You see, I have two. This is the local loopback, and you can see that's got the common loopback address there that we have in Windows as well. And then this one is the one my physical Ethernet adapter I want to adjust. So ethconfig0, and I want to change the IP address to 10.10.10.70, let's say. Okay? And now if I do an ifconfig again, we'll see that I've now changed my IP address to .70. And then again, if I would rather actually use the UI to work with the IP address, I can do it a couple of different ways. I can go to System, Administration, and then Network Tools. And you can see here that it takes us into this. And then I choose which interface I want to work with, Ethernet 0. And then I can double-click into this and configure it as necessary. So I'll just go to this and then choose Edit. And then I can change the IP4 address as necessary, or, and I'm going to back out of all of this, probably a more direct way to do this, if you have a single interface that you want to work with, is simply to go to these up-down arrows that we see up here. That's actually a symbol for my network connection. I'll go to Edit Connection, and then I can go directly here to choose Edit. And then now you can see, it's kind of self-explanatory, but you just double-click in here, and you change the IP address to whatever you want to, the subnet mask, and so forth. Let's take a look at some Linux command as well. I've already talked about these two to change directory and to list the files that we see here, but there's also the grep command, and that can kind of come in handy, well, with things like ls, in fact. Let's take a look. So if I go to my terminal right here, and I go to a directory that's pretty busy, let's change directory to, the bind directory. If I do an ls here, you can see that there's quite a few different commands in this, and I can't see the forest for the trees, but I know what I have has the letters MOR in it, or maybe I can't remember the exact name of the file I'm looking for. So what I could do here is an ls, and then I could do a pipe grep, and I can't remember exactly what it has, but it has an MOR something in it, and I press enter. And that would then show me any of the commands here that have MOR. Okay, so it's kind of a handy way to filter down your results using the grep command. Another way that could be used is in various processes that might be running. So, for example, if I were running VI, and I'm going to have to open up a separate window here, but actually let's just do it this way. If I open up a separate window and do VI, and I'm trying to edit some text in here, and I'm typing along and so forth, and suddenly maybe it somehow hangs or something like that. It does happen in Linux, just the same way it does happen in Windows, although probably not as often. So anyway, if I wanted to kill that, what I would have to do is to type kill, and I'd have to know the process of it, though. So what I would do is I'd do a PS, capital A. Now, there's a lot here, okay, and I might not be able to find the exact one that I'm looking for. Now, in this case, it's going to show up at the bottom, and so I just happen to know that it's right there. But if I can't see the forest for the trees, I could use the grep command again, A, and then I could do a grep for VI. And that would show me anything that has VI in it. In this case, I see the process as 3562. And I could kill with a -9, 3562. Now on -9, it's kind of a graceful kill, so it's not quite as forceful as some of the others. I could also do a kill -15, and that would forcibly terminate it, without apology. But I could press enter here, and it seems to have closed itself out just fine. If I were to type it again, VI once again, and I wanted to kill it forcefully, I could just replace that with a 15, rather a -15. Oh, you know what else? I got to find out. Got to find the process number of it, because when you restart it, it's going to have a different process number here as well. Okay, so I'm going to go ahead and go through my commands here again, and let's see, that would be 3567. Move the cursor so you can see. And then I want to forcibly kill it, which isn't really necessary in this case, but you could if you absolutely had to, if it was really causing you some problems. And then that we can see here that I caught a deadly signal term. And I'm finished! A little bit dramatic, but at least we know that the program now has been killed. Let's also talk about super user, or SU. This is what you would need to use if you were logged in as a non-privileged account, but you needed to do some kind of an administrative action that required root privileges. If you type in SU in front of the command you're trying to do, then it would prompt you for the root credentials. And you'd have to know those, of course, and type them in. If you're logged in already with an administrative level account, but it's not the root account, then you would type in sudo, and that would give you, just confirm that you do have the credentials. It's a lot like Windows user account control. People get on Microsoft a lot for Windows 7 and Server 2008's user account control because they find it annoying. However, we've always had that in other operating systems too, including Unix, Linux, Mac OS, all of them. Here I'm logged on as a trainer account, and let's say that I'm not happy with the IP address I've got. I have config, it's at .70, and I realize, oh, you know what? That's the wrong one. So if I were to just try to change that here, even though I have administrative access, I would do an ifconfig eth0 and then change it to 10.10.10. Let's say 90. Oops, permission denied. So what I would do instead here is I would do a sudo ifconfig eth0 and so on, and then it would ask me for the password for the trainer account, which I type in, and then what we'll see here is that we have now got that IP address changed because I was able to elevate my privilege. Now, this other thing that we would do, where we use just SU, you could do that. Actually, let me go back here. I could just type SU and press enter, and that would ask me password. Well, password for what? Anytime you use SU for super user, that's always asking the password for the root account, and I hope I remember it. There we go. Okay, so now I'm root. You can see that I'm a root in this directory, and that's just another way of elevating my privilege. And that might be important to do for various purposes. Now, if I exit out of that, that takes me out of the root credentials. Anything that I would have typed in here while I logged in as root would have allowed me to continue those commands as if I were the root, okay, because I knew those credentials. We also have the ability to change the password using the passwd item, and I can do that here as well. If I'm logged in, right now I'm logged in as root, if I want to change the password, I would just do a passwd, and then enter the new Unix password, and let's just say, trying to remember a good one here. Okay, and so I've updated my password successfully here. It doesn't show asterisks or anything like that. I just typed in the password and confirmed it, and there we go. So that's going to be important to know how to change a password. Now, that's not to be confused with PWD, which you would think that would be password or an abbreviation for it. But remember, that's actually what shows you what directory you're currently in. There's also PS, which is what we saw earlier. Normally, we'll use PS-A to show us any processes that are running. And then if we want to kill any of those processes, we can use the kill command. Now, we've already talked some about Linux account management with regards to the root account, which is the equivalent to the local administrator in Windows, but you can also add additional accounts using user add. So if we wanted to do this from the command line, we would simply type in user add, and then the name of the account that we wanted to create. Maybe you want to create Trisha. Something like this, for example. And then if you wanted to work with her password, because right now she doesn't really have a password, so we'd have to do, I guess I'd have to type that in as well. It's not on this slide, but we talked about it earlier. I would type in PASSWD, Trisha, okay? And then we would enter in the password for Trisha. Can't I think I might have typed it wrong. Anyway, you'd have to enter in the password for Trisha, and you'd have to make sure that the passwords match. Let me try it again. Okay? All right, there we go. So we've now got a password and an account created here for Trisha. I can also change properties of that user account by changing. You can do a lot of things. I could change their home directory. I could change their group memberships. Let's just do that, in fact. Let's go to the group membership here of this user. And who was that? Trisha. So let's just do user mod. The group that I want her to belong to is, let's just say, the users group, which is kind of similar to what we would have in Windows as well. And the account I'm trying to change that for is Trisha. And enter. So now we've been able to change her group membership. Now, there is UI for all of this stuff as well. So if we wanted to go into System, Administration, and Users and Groups, then we could see these accounts that we have just created from the command line, but we could just as easily work with these accounts from this UI as well. And not getting any love out of this, it seems. Oh, that's right. I'm logged in as root right now. And what you have to do is the root account actually doesn't work with some of the UI settings under the current Ubuntu distributions. And that's partially, I think, to discourage or logging in as the root account. Now, only for this particular nugget am I using the root account to make things simpler for everybody. However, in future nuggets, I'm going to be logging on as the trainer account. I'm just going to switch over there right now so you can see what that looks like. And so then here I've got user settings open, and if I wanted to make a change to, for example, Trisha's account, maybe I spelled her name wrong, I could just click change here. You do have to enter in the root password. Hopefully I got that right. There we go. And then the full name for Trisha is actually supposed to be, maybe it's Trisha, and I got that wrong. By the way, notice that I'm spelling the names lowercase. This is a little bit of a difference, a little bit of a switch up for me, because I'm kind of particular about spelling people's names properly, and usually you're supposed to capitalize the name of the person, aren't you? Well, you are. However, in Linux, when you create an account, let me just go ahead and show you this. If I create another account like Howard, and I got a capital name up here, notice that it puts a lowercase here for username. That's because the actual name that the person goes by, like this, for example, the kind of the user-friendly name, you can capitalize, but their literal username that they use to log on is always lowercase. Same with trainer back here in the background. I capitalize the name, but in reality, the logon name always has to be lowercase because it is case sensitive, and you can see some of the description of that right there. Also, when I enter in Howard's password, try to enter that in here. Very similar to what we do from the command line. Just have to enter it in and confirm it. You can also generate a random password if you want to, or don't ask for a password, but that's not usually very security smart. Then if I wanted to change Howard's group memberships, for example, if I go to Manage Groups, then I could just add him to a specific different group if I wanted to, if we had a specific purpose for this group and we wanted to give him a different level of privilege. Also, I could go to Advanced Settings here and go down to his, we can enter in some additional information for him here. I can look at the user privileges that he has the capabilities to do here as well. Depends upon what level of access you want the person to have. Most of the time, you don't need to go through all of this. However, usually you can just make them a desktop user or an administrator for most users. And so then if I wanted to delete one of those accounts, I could just go to Trisha here, for example, and choose delete. Then I can also keep or remove her files because it creates a home directory for her. If we really don't care about the files, we can delete those, of course. Otherwise, maybe if they're sensitive files that we need to keep around for work purposes, we would want to keep those and probably move them to some other location. And then from the command line, if you needed to delete an account, let me just show you how you would do that. I could go down here to sudo, because I'm logged on with administrative access, but if you're not logged on as the root account, then again, you have to do a sudo, which is going to elevate my privilege. But I'm going to do a user delete, and I want to remove their directory as well, like their home directory. And then the name of the account, like Howard's account here, and I'll press enter. Ask me for the password for trainer. Hopefully I typed that in right. There we go. Okay, so now I've just deleted Howard's account as well. And so in all that, we saw how to delete the user as well as these other things we've already discussed. And we also saw how to work with the UI there. All right, now let's quickly take a look also at installing Linux apps. This really kind of goes beyond installation of apps, but it also goes into archiving and compressing files, which sometimes you'll need to do. For Windows admins, maybe we've used WinZip in the past, or the native zip capability within Windows, where you can select multiple files or folders and then send them to a zip. And you can do similar things here in Linux as well. To archive alone, that would be where you'd want to put them in a tar file. This doesn't mean that they're compressed. It's just like collecting a bunch of files and/or folders and stuffing them into a single tar file. You can also compress them. You can use zip by itself, and that would be useful if you wanted to zip a single file or a folder, and that would be very similar to the compression algorithm that we have in Windows. You can also use gzip there as well. And then you can also do a tarball, and what that would do is it would create a file very often that ends in .tar.gz, and then there's a newer one there that would end in .tar.bz2. That's just a higher, I'll put .bz2. You don't have to memorize that, but that's just a higher level of compression if you want to use it. But let me just show you how I would do that if I was just working with those files. And again, the importance of that is because a lot of the applications that we'll work with are actually going to be in a tar format of some kind, or maybe compressed and tarred. So here I just have a few files that I've created here, and what I could do is I've already pre-typed this in, so you don't have to watch me type the whole thing, but I'm running tar and then a -zcvf. This will compress and tar the files, and it's going to be created in a document called my files, and then it's going to tar and compress myfile01, myfile02, and myfile03. Now, if I wanted to make it more intuitive, I can also do make this a tar.gz if I wanted to, but if I don't, it'll still actually do that, because remember, in Linux, the extensions don't mean anything. So even if I leave those extensions off, it'll still be a tar, it'll still be compressed. But to make it intuitive, I'll enter it in that way. And then now we can see it right here. There's myfiles.tar.gz. And then if let's say I deleted these files or I didn't have them in the first place. Maybe somebody emailed this to me and I needed to extract them. How would I do that? Well, you could do that from the command line here as well. And I would just do something like this right here, tar, and then I would extract them using this sequence here, and then the name of the file, and press enter, and then we would see that indeed those files now do appear as well. Now, if you want to use the UI instead, certainly you can do that. If I just select all of these files and then right-click, I can also go to compress, and notice that it gives you several options there. Some of these are a little bit more obscure than others, but these middle three right here are the more common ones that you can use. This would be probably a very common one right there. And I could just give it a name here. I'll just call this, put a cursor in here. And I'll just call this my tar or something like that. My tar files or whatever. And I'll just create that. There's also other options that you can see here as well if you want to put a password on it, for example. But I'll just go ahead and click on create, and then now I've got these my tar files. Likewise, using the UI as well, I can just double click on it. It shows me these. If I only wanted to extract one, let me just get rid of myfile03. Maybe that's the only one I really needed out of this whole tar item. I can just click and drag that. And drag that right into, if it lets me, there it goes. Drag that right into this, and then there's my file right here. And then for the rest of this, as far as installing Linux applications goes, let me just start from the bottom here. I'm going to go out of order here and start with Red Hat Package Manager, which obviously was designed for Linux distributions of the Red Hat versions. And what I could do with that is to use RPM, which is the command line version, to install or decompress and extract all the files necessary for an application, and then install it. And it, of course, works just great in Red Hat. Now, I can still use it in a Debian distribution like my Ubuntu that I'm working with here, but it'll kind of give you a little bit of a warning there as well. So let's go ahead and take a look at what you would work with that. What it'll tell you is to use Alien instead, and what that'll actually do is it will convert your Red Hat Package Manager file into a .deb file, which is more native to Debian operating systems like Ubuntu. Alright, now I've downloaded a utility called Nmap, which is a very powerful utility that most hackers will be very well familiar with. It's a port scanning type of a utility. Anyway, I've copied that to my download directory, and I need to move it over to the USR local directory. That's just where I like to work with various files. You can really put it wherever you want to, but in my case, since I'm going to be doing that particular directory, I need to elevate my privilege. So I'm going to do sudo and then mv for move. And then it's going to be home, trainer, and then downloads, and then nmap, like that. And then I'm going to move that into USR local. Okay, so I'm going to move it over there. And the password, and there we go. All right, now the next thing I want to do is I'm going to change to that USR local directory, and just confirm that I've got it. And you can see that nmap is there right now. Now, what do I need to do in order to get RPM going here? Now, this is going to be where we're going to jump around a little bit. I'm going to go right back to the slide here for just a moment. Make note of this item right here, apt-get. You see, if I wanted to use Red Hat Package Manager to unpack and install Nmap right here, I wouldn't let me do it right away. Let me show you why. RPM, and then I want to do an install of Nmap. But I actually don't have the Red Hat Package Manager here yet. And it's telling me as much right here. It's not currently installed, but I can get it by doing this. This is one of the things I like the most right now about a lot of different distributions of Linux. It makes installation so much easier. In the past, you'd have to just go on a bug hunt and Google all over the place to find the various dependencies and the latest versions and everything that you'd need to get whatever you needed. In this case, Red Hat Package Manager. But in this case, I can just do a sudo apt-get install RPM, and if it's something that the system knows about, it knows what websites to go to and so forth to get the latest or most stable version for my purposes. It asks me if I want to install it. I say yes. That's pretty much all there is to it. It's pretty much done all the work for me at this point, and it's going to save you an awful lot of time just using that apt-get install, and then you follow that with whatever the utility or the package is that you need to install. And then even once I've got RPM, it might still not be advisable. Let me show you what I mean. If I do this command here again, now I've got RPM, so it should be able to work with it, right? But watch what happens when I do this. It's going to tell me up here at the top that there were some failed dependencies, and I should be using Alien instead. So what am I going to do? Sudo apt get install alien. I think actually I have it installed, but let me just double check. No, I guess I do need to install it. So I'll go ahead and get that going. Now, what does alien do for me? So what I was mentioning on the whiteboard just a moment ago, that's what's going to convert a Red Hat package file to a Debian file, and then it will be in more of the native format that a Debian Ubuntu here will be able to work with. So I'm going to go to sudo alien, and then what's my command here? Nmap, like that right there. And do I have everything I need? Yeah. I'm just going to press enter. And then what that's going to do is in just a moment it's going to return to me that it's created that package for me, and there it is. So now all I have to do is to do the Debian package manager. Oops, let me move my cursor in here. Debian package to install that, and then nmap, and then it's going to be an underscore. It also does slightly different, punctuation and so forth. Notice that the original was a hyphen. Here now it's an underscore. I'm not sure exactly why they do that, other than to make it a little bit more distinctive. And now I'm going to go ahead and install that one. It requires super user privilege. Almost forgot. So I got to do sudo. And then that's pretty much it. Now let's go ahead and take a look at Nmap, and I'll go ahead and clear the screen here. We'll be using Nmap a lot of different times throughout this series. But let me say I wanted to do a scan. A -st is a common one that I could do using a TCP scan, and I wanted to scan against a Windows host I had over here to look for open ports over there to see what it can work with. And then once the command runs, we see that we have a few different ports open for various purposes. For example, it's probably a domain controller. Really good chance, in fact, because it says it's Kerberos and it's opening on port 88. It's also using port 445. That's another common Active Directory port that it would be using. And so there's some symptoms there that we can see that it must be an Active Directory server. It's probably also got WSUS running because it's got a web page over there. It's usually advisable to put the WSUS, which is a way of updating your Windows clients, on an HTTPS connection instead, and we do have HTTPS available as well. So this is giving me some hints as to what ports are open. Maybe they're using some virtual private networking because there's PPTP open as well. So this might give me an opening into hacking that system a little bit later on. Now, as I work my way up here, we're going to work with this bullet right here. What's going on with this is a lot of the hackers utilities out there are very flexible and allow you to custom program or to do your own things with them. Most of them are in the C language programs. And if they're sent out as the source files, then you need to compile them so that you can then use the make command to be able to put everything in the format necessary to actually run the program. Because you don't, in Windows, normally don't get the source code. You just have a .exe or a .msi file or something like that. Well, here we need to configure the files to create a make file. Once you have a make file, sometimes you'll just run that, and that's all you need to do. And then sometimes you'll also need to run make install. You just have to look at the README file for whatever it is that you're trying to work with. And in my case, I'm working with the libpcap. You can see that I've copied it here to USR local. Again, I'm logged on as a trainer account, so I'll need to sudo just about everything I do here. And what I want to do is to, first of all, run the tar command to run xzvf. It doesn't really matter what order you type those letters in, but tar that, and I'm looking for libpcap. Okay, and that right there. And what that's done now, if I do a ls, is you can see that it's now created the libpcap directory. And then you can see after I've cleared the screen here that I've changed to the libpcap directory. And if I do an ls here, you'll see that there's a configure file up here close to the top, right there, that green one. So what I would want to do here is I would just want to type configure. Actually, I'd have to do a super user as this as well. But if I just type configure, even though I'm in the proper directory, it says command not found. Well, we just looked at it, so I know it's there. Why is it giving me that? Well, in Linux, if it's not in the path statement, you have to be explicit with it. So I'd have to do a ./configure, unlike what we would do in Windows, where if you're in Windows it's in the proper directory, even if it's not in the path statement, it'll still go ahead and run it. Here I have to do it that way, and again, I got to get used to typing sudo, don't I? I have to do sudo here, and then it's just go ahead and creating a make file for me. A lot of times these things will run through certain scripts or other instructions to give you all of the contents that you need. Now if I do an ls here, you may notice that there's a few more files here than there were before. That's because of the configure command that I already typed in. Hopefully you memorized the previous screen so you can do an exact comparison of all the files we have on here. Okay, you will be tested on that. I'm just kidding, you won't be. Anyway, so now what I want to do is to just type make. That's pretty much all I have to do. Okay, and it's just going to go ahead and take care of all of that for me. The instructions are all kind of pre-packaged there, so I don't have to figure any of that out. And then I really can't even remember if I'm supposed to do a make install. So let me just look at the instructions. There's either a readme, or in this case, I think there's an install.txt. So I'm going to do a vi install.txt, and it'll tell me what I'm supposed to do. Okay, so .configure, run make, and then run make install. So I definitely have to do that here. I'm going to just go ahead and quit this out. And I'm going to go ahead and sudo, and then it's going to be a make install. I'm still in the proper directory, so I'll just press enter and let that go. All right, now I've just installed the libpcap. Now this doesn't really do anything by itself. It's really just used by other applications for things like promiscuous network sniffing. So I'm going to go ahead and change directories here. Up a level, space, and then ... will take me up a level. And then we see here that I have my TCP dump command. I'm going to basically do all the same things that I just did for libpcap. I'm going to do all the same things for TCP dump. And in the interest of time, I'm not going to show you all the exact commands, just the same stuff that I already did, just a different file name is all. And then now after the installation is all completed, I can just run TCP dump. And I'm not sending this out to a file. I'm just going to show it in, I'm going to do a sudo again. I keep forgetting that. And then it's going to go ahead and show me any packets that it's able to capture on the network. So if I were to go off screen here and open up another web page here, for example, to my own web page, for example, then it would show some traffic going back and forth to that as I browse through photos and stuff like this. So anyway, you can see that it's just kind of doing a whole bunch of different stuff here. And normally you would send that out to a file and then analyze it later on. But I'm going to go ahead and kill that for the time being. And we see that we captured quite a few packets there. Okay, so there's several tools that do that kind of packet capture. I'm just using that one as an example. In this nugget, we talked about VMware and Linux. We started off by taking a look at the security, functionality, and ease of use triangle. And remember, the closer you get to one of those points, the further away you get from the other two. Certainly, of course, we want to get closer to security, but that's often at the expense of functionality or ease of use. We also took a look at the 5 stages of a hack, and really that's kind of an overall summary of what we're going to be addressing throughout the rest of this series, really. We took a look at VMware. This is a critical tool to be able to use. Probably costs a couple $100 by the time you're done paying with tax, maybe if you have to pay tax in your area. So it's a little bit pricey in one respect, but it's so very useful that I strongly recommend it. If you really just can't part with that kind of money, you might consider getting VMware, what do they call that? VMware Player. And that's a free download, but it doesn't have all the functionality that the full-blown VMware Workstation does. There's also Linux, which of course took the majority of our time here, and it's very important to know about Linux, so be as sharp as you can on Linux. It'll help you get further as you perform your hacks. Well, I hope this has been informative for you, and I'd like to thank you for viewing.